Welcome to the DEFCAM. Despite heavy Indian lobbying and diplomatic pressure, reports indicate that Russia has quietly approved the potential supply of the RD-93MA engine for the Pakistan Air Force, a move that carries both technical and strategic weight in the evolving South Asian balance. For Pakistan, the decision represents an opening that could transform the JF-17 Block 3 fleet and reinforce the broader PFX program with a propulsion system designed to overcome long-standing limitations in thrust, reliability, and lifecycle support. The RD-93MA is not merely a derivative of the earlier RD-93 fitted to the baseline JF-17, but an extensively refined powerplant incorporating advances drawn from the RD-33MK series used on MiG-29 derivatives, with enhancements in thrust output, digital control, hot section durability, and thermal efficiency. From a technical standpoint, the RD-93MA offers a maximum afterburning thrust rating of over 9 metric tons compared to the roughly 8.5 metric tons produced by the current RD-93 variant, which directly impacts takeoff performance, climb rate, and sustained high-G maneuvering. The engine is fitted with a full-authority digital engine control system that improves throttle responsiveness and reduces pilot workload, while optimizing fuel flow and thermal loads across a range of conditions. This ensures smoother integration with advanced avionics suites in the JF-17 Block 3, where sensor fusion and helmet-mounted display systems demand seamless power response during complex engagements. Enhanced turbine materials and cooling technologies extend the mean time between overhaul, reducing downtime and increasing sortie generation rates. Operationally, the thrust-to-weight ratio of the JF-17 Block 3 airframe improves significantly with the RD-93MA, permitting carriage of heavier sensor pods, electronic warfare packages, or long-range precision weapons without a detrimental effect on performance. The aircraft can operate at higher altitudes with greater endurance, which broadens the reach of its radar and missile envelope. High thrust at medium and high altitude enhances the employment of beyond visual range missiles by allowing launch from advantageous kinematic conditions. For strike roles, improved thrust output translates into the ability to carry a larger payload of precision-guided munitions or standoff cruise missiles while maintaining acceptable acceleration and maneuver margins to evade interceptors. Reliability is an equally critical factor. Earlier RD-93 units faced scrutiny over hot section wear rates, smoke emission, and fuel efficiency, which limited endurance and imposed higher maintenance requirements. The RD-93MA addresses these concerns with upgraded high-pressure turbine blades, improved combustor design for cleaner burn, and materials engineered to withstand higher operating temperatures. Lower specific fuel consumption directly increases mission radius, enabling deep strike profiles without the need for extensive aerial refueling support. For a country like Pakistan, where force multipliers such as tankers are limited in number, an engine that delivers additional range from internal fuel is an invaluable strategic asset. The integration of the RD-93MA also has implications for the upcoming PFX program, which seeks to push beyond the JF-17 architecture into a new platform with advanced avionics, electronic warfare suites, and potentially a more stealth-conscious design philosophy. A reliable and high-thrust Russian engine available in sufficient quantity would provide a proven propulsion backbone for prototypes and early production runs, while indigenous or collaborative engine programs are still under development. It offers a pathway to accelerate timelines by removing propulsion as a bottleneck, allowing the focus to remain on developing advanced mission systems and weapons integration. For India, the potential supply of RD-93MA engines to Pakistan raises a strategic dilemma. New Delhi has long assumed that its influence in Moscow, backed by decades of large-volume defense purchases, including Su-30 aircraft, tanks, and missile systems, would prevent Russia from approving critical technology transfers to Pakistan. The reality that Russia is prepared to pursue limited but high-value cooperation with Pakistan despite Indian objections demonstrates shifting priorities in Moscow's calculus, where diversification of partners and access to growing defense markets outweigh historical constraints. It also reflects recognition that Pakistan is playing an increasingly important role as a testing ground for Chinese-Russian integrated technologies, with platforms like the JF-17 serving as real-world laboratories for propulsion, sensors, and munitions in contested environments. From Pakistan's viewpoint, the acquisition of RD-93MA engines is not solely about matching Indian capabilities, but about securing long-term sustainability for its combat fleet. With the JF-17 program now forming the numerical backbone of the Air Force, and the Block 3 variant introducing indigenous radar, data links, and weapon packages, propulsion is the last major frontier where dependency could undermine the aircraft's full potential. By locking in a higher-performing and more durable engine, Pakistan ensures that its largest fighter program remains operationally credible well into the next decade. This stability allows planners to phase out aging fleets of legacy Mirage and F-7 aircraft while maintaining force levels sufficient to cover both eastern and western fronts. Tactically, improved engine performance enhances survivability in contested airspace. Faster climb rates enable rapid transition to altitude, reducing vulnerability during the takeoff phase. Greater thrust in turning engagements improves energy retention, a factor decisive in within-visual range combat. Increased acceleration permits quicker disengagement or pursuit when missile warning systems cue evasive action. These margins collectively strengthen pilot confidence and operational flexibility, attributes that cannot be quantified solely by thrust figures but directly affect outcomes in real combat. The supply of RD-93MA engines also signals to the international defense community that Pakistan continues to attract advanced technology despite attempts at isolation. It highlights the credibility of Pakistan's aerospace ecosystem, which has demonstrated the ability to absorb, integrate, and sustain complex power plants across large fleets. By coupling Russian propulsion with Chinese avionics and indigenous weapons, Pakistan is refining a model of hybridized technology management that avoids single-source dependency and optimizes value across suppliers. This diversified model reduces vulnerability to sanctions or embargoes and ensures continuous modernization despite shifting geopolitical winds. On the industrial front, Pakistan's experience with the RD-93 lays the groundwork for local maintenance, overhaul, and possibly partial manufacturing of RD-93MA components in the future. Each expansion of technical cooperation creates opportunities for skill transfer, tooling upgrades, and the training of engineers and technicians who form the core of indigenous capability development. The presence of an advanced engine fleet inside the country spurs demand for precision metallurgy, high-temperature coatings, and digital diagnostic systems, all of which contribute to the broader national industrial base. Strategically, the arrival of RD-93MA engines feeds directly into Pakistan's deterrence posture. With India inducting Rafale fighters equipped with powerful engines and advanced electronic systems, parity in the propulsion domain ensures that Pakistani fighters remain competitive in terms of energy maneuverability and payload delivery. It closes a gap that adversaries might otherwise exploit in planning deep interdiction or air superiority campaigns. The psychological dimension of knowing that one's fleet is not outclassed in engine performance strengthens both pilot morale and strategic deterrence. Furthermore, access to the RD-93MA provides Pakistan with options in its evolving partnerships. While China is actively developing indigenous engines such as the WS-13 and WS-19 for use on platforms like the JF-17 and J-35, these programs face the usual challenges of maturing reliability and establishing production consistency. The Russian engine supply acts as a bridge, ensuring that Pakistan does not suffer capability shortfalls while waiting for alternative solutions to fully materialize. It also creates competitive pressure on suppliers, encouraging them to deliver higher quality products at better terms. In broader geopolitical terms, Russia's willingness to authorize this transfer despite Indian concerns points to a more multipolar defense environment in which historic alignments are less rigid. For Pakistan, this outcome validates a policy of strategic diversification, engagement with multiple partners, and careful calibration of relations to ensure continued access to technologies that underpin national security. It also provides leverage in regional diplomacy by demonstrating that Indian pressure cannot completely isolate Pakistan from high-end defense markets. In conclusion, The prospective supply of the RD-93MA engine for Pakistan's JF-17 Block 3 and future PFX program represents far more than a propulsion upgrade. It is a comprehensive enhancement that addresses tactical, operational, industrial, and strategic dimensions of national defense. It boosts thrust, reliability, endurance, and payload flexibility, directly translating into combat effectiveness. It provides continuity and growth for Pakistan's most important fighter programs, stabilizing fleet structure and ensuring future readiness. It undermines adversary assumptions about the effectiveness of diplomatic pressure campaigns and highlights Pakistan's ability to secure advanced technology in a contested international environment. Above all, it represents a decisive step in aligning air power capabilities with the demands of modern aerial warfare, reinforcing national security and ensuring that Pakistan retains the ability to deter, defend, and project air power across the region. Thanks, and stay connected to the upcoming videos.